The afternoon of June 19th, 1944. You're standing on the flight deck of the USS Enterprise, somewhere in the Philippine Sea, watching the deck crews hustle around rows of Grumman TBF Avenger torpedo bombers. The sun is brutal, the deck shimmering with heat, and there's a tension in the air that makes every breath feel heavy. Your squadron commander just briefed the mission. The Japanese mobile fleet has been spotted, 275 miles away. That's not a typo. 275 miles of open ocean between your carrier and the enemy, and you're looking at a fuel gauge that says this is going to be close. Very close. Here's what makes this moment extraordinary. The Japanese admirals commanding that fleet, men who had planned for this decisive battle for months, men who had studied American carrier doctrine obsessively, are completely confident you can't reach them. Their intelligence says American torpedo bombers have an effective combat radius of maybe 200 miles. 275 miles puts them safely out of range. They're wrong, dead wrong. And in about 2 hours, if you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. When TBF Avengers start dropping Mark 13 torpedoes on their carriers from altitudes and distances the Japanese High Command said were impossible, that miscalculation is going to cost Japan the war in the Pacific. Admiral Jizaburo Ozawa was not a stupid man. The commander of Japan's mobile fleet in June 1944 was one of the Imperial Japanese Navy's finest tactical minds. He'd been planning for this battle, what the Japanese called the decisive engagement, since taking command earlier that year, and his plan was sound. Brilliant, even, on paper. The key to Ozawa's strategy was range. Japanese carrier aircraft in 1944 could scout out to 560 miles and attack at ranges up to 400 miles. American aircraft, according to Japanese intelligence, could scout to about 350 miles and attack at maybe 200 miles. That was a massive advantage. If Ozawa could find the American carriers first, and he was confident he would, his aircraft could strike from well beyond the range of American counterattack. But Ozawa's advantage ran deeper than just aircraft range. The Japanese plan, designated A-Go, called for something the Americans couldn't match. Shuttle bombing. Ozawa's carrier aircraft would launch from maximum range, strike the American fleet, then fly onward to land at Japanese air bases on Guam and the other Mariana Islands. There they'd refuel, rearm, and strike the American fleet again on their way back to the carriers. It was elegant. It effectively doubled the striking power of his aircraft. 1 plane, 2 attacks, and the Americans would never see the carriers that launched them. There was just one problem with this perfect plan. The Americans had destroyed most of the Japanese air bases on Guam before Ozawa's fleet even arrived. Task Force 58, under Vice Admiral Mark Mitcher, had been pounding the Marianas for days. Strikes on June 11th, 12th, and 13th had wrecked the carefully prepared airfields. Of the 500 land-based aircraft Ozawa was counting on to support his fleet, maybe 50 remained operational. But Ozawa didn't know this. Japanese communications in 1944 were increasingly unreliable. The air units on Guam kept reporting they were ready for operations when they were barely functional. So on the morning of June 19th, Ozawa launched his attack, still believing his shuttle bombing strategy would work, still confident the Americans couldn't reach him. The first Japanese strike wave departed at 8:30 M169 aircraft. Ozawa launched them from a position about 330 miles west of the American fleet, well outside what he believed was American strike range. His aircraft would hit the Americans, land on Guam, hit them again, and return to the carriers. Meanwhile, American aircraft would be stuck on their carriers, unable to reach Ozawa's fleet. Except that's not what happened. What happened instead was a massacre that American pilots would later call the Great Marianas Turkey Shoot. American radar picked up the Japanese aircraft while they were still over 100 miles out. The new radar systems on ships like the Enterprise and Lexington could see farther and track more accurately than anything the Japanese had. Fighter directors aboard the carriers vectored 53 Hellcat fighters to intercept. The Hellcats tore into the Japanese formations like wolves into sheep. The Japanese pilots Ozawa had launched weren't the veteran aviators who'd struck Pearl Harbor 2.5 years earlier. Those men were dead, killed at Coral Sea, Midway, the grinding campaigns in the Solomons. These were replacement pilots, many with less than a year of flight training, against American pilots who'd been training for 2 years and had the benefit of veterans rotating back to teach them everything they'd learned in combat. It wasn't a fight. It was slaughter. Of the 169 aircraft in that first wave, only 27 survived to return to Ozawa's carriers. Not a single American ship was sunk. One battleship took a bomb hit that killed 27 men but left the ship fully operational. Ozawa launched 3 more strikes that day. Each one met the same fate. American radar saw them coming. American fighters destroyed them. By the end of June 19th, Ozawa had lost 350 aircraft. The Americans had lost 30. But here's what matters for our story. While those Japanese aircraft were being systematically destroyed, nobody on the American carriers was launching strikes against Ozawa. Because the American commanders didn't know exactly where the Japanese fleet was, search aircraft had been out all day, scouring hundreds of square miles of ocean, and they'd found nothing. The Japanese fleet was too far away. Beyond the range where American search doctrine said to look, at 3:40 p.m., Lieutenant Robert Nelson, flying a TBF Avenger from the Enterprise, spotted the Japanese fleet, 275 miles west of Task Force 58. Nelson immediately radioed the position, and that's when Admiral Mark Mitcher made the decision that would prove Ozawa's intelligence completely, catastrophically wrong. Mitcher ordered an immediate strike. Every available aircraft, fighters, dive bombers, and torpedo bombers, including the TBF Avengers. The staff officers on Mitcher's flagship, the Lexington, were horrified. 275 miles was beyond maximum range for a torpedo strike. The TBF Avengers carried a Mark 13 torpedo that weighed over 2,000 pounds. With that load, the Avenger's combat radius was supposed to be around 200 miles, maybe 220 if you pushed it. Launching at 275 miles meant most of the aircraft wouldn't have enough fuel to return. Pilots would have to ditch in the ocean. The losses could be catastrophic. Mitcher looked at his staff and said, "Launch them." This was the chance to destroy the Japanese carrier fleet. If they waited until tomorrow, Ozawa might escape. The aircraft launched at 4:21 p.m., 216 planes, 85 Hellcat fighters, 77 Dauntless and Helldiver dive bombers, and 54 TBF Avengers carrying Mark 13 torpedoes. Now, let's talk about what made this possible. Because this wasn't just about brave pilots willing to risk ditching in the ocean. This was about a weapon system the Japanese didn't know existed. The TBF Avenger that took off from American carriers in June 1944 was not the same aircraft that had debuted at Midway 2 years earlier. Grumman and the Navy had spent those 2 years fixing every problem, pushing every performance envelope, turning a good design into something extraordinary. The original TBF-1 that entered service in 1942 had a range of about 1,000 miles with a full torpedo load. That sounds impressive until you remember that combat radius, the distance you can fly to a target and still have fuel to return, is roughly half your total range. So 500 miles out, 500 miles back. Factor in combat maneuvering, which burns fuel fast, and you're looking at a combat radius of maybe 200 to 220 miles with a torpedo. But by 1944, the Avenger had evolved. The TBM-3 variant, which started production in April 1944, had a more powerful engine. The Wright R2620 produced 1,900 horsepower compared to 1,700 in earlier models. More importantly, the TBM-3 could carry external fuel tanks, 3 drop tanks, each holding 335 gallons, mounted under the wings and fuselage. With those tanks, an Avenger's range jumped dramatically. The Mark 13 torpedo had also been completely redesigned. The torpedo that Devastators had carried at Midway was a disaster, unreliable, fragile, limited to drop speeds of maybe 130 miles per hour and drop altitudes of less than 100 feet. By late 1944, the Mark 13 Mod 2 had been developed with wooden stabilizing fins and a crushable nose cone that allowed drops from as high as 800 feet at speeds up to 260 knots. The Torpedo ran faster, more reliably, and its warhead had been upgraded from 400 pounds of TNT to 600 pounds of Torpex, an explosive 50% more powerful than TNT. But the real game-changer was something the Japanese had no idea about: attack profiles. American doctrine in 1944 had moved beyond the suicidal low-level approaches that had killed so many torpedo bomber crews at Midway. The new Mark 13 could be dropped from altitude, which meant Avengers could approach a target at higher speeds, from better positions, with more fuel efficiency. An Avenger, diving to a release point at 800 feet, could achieve speeds that cut flight time significantly. Less time in the air meant less fuel burned. It meant you could fly farther on the same tank of gas. So when those 54 Avengers launched at 4:21 p.m. on June 19th, they weren't the lumbering torpedo planes the Japanese expected. They were long-range strike aircraft capable of hitting targets the Japanese thought were unreachable. The formation flew west into the setting sun. It took them over 2 hours to cover 275 miles. By the time they arrived over the Japanese fleet, the sun was low on the horizon. Light was fading, and every pilot knew they were flying into a fuel nightmare. The attack itself was chaos. Japanese combat air patrol fighters rose to meet them. Anti-aircraft fire from the Japanese ships filled the sky. American Hellcats engaged the Zeros, while the dive bombers and torpedo bombers pressed their attacks. Lieutenant Commander Robert Easley led the Avenger strike from the Belleau Wood. His squadron attacked the light carrier Hio from multiple angles. The improved Mark 13 torpedoes, dropped from higher altitude than the Japanese expected, ran true. 2 torpedoes struck Hio on the port side. The explosions ripped open her hull below the waterline. Fires broke out immediately. Hio's damage control couldn't contain the flooding. At 6:32 p.m., less than 90 minutes after being hit, Hio rolled over and sank. 1,200 men went down with her. Other Avenger squadrons attacked the fleet carrier Zuikaku, one of the last survivors from the Pearl Harbor strike force. Several torpedoes hit, causing significant damage, though Zuikaku managed to survive and limp away. The carrier Junyo took a bomb hit from dive bombers. The battleship Haruna was also hit. It wasn't the complete annihilation of the Japanese fleet that Mitchell had hoped for, but it was devastating enough. One carrier sunk, others damaged, and it had been done from a range the Japanese said was impossible. Then came the nightmare flight home. Darkness fell completely by 7 p.m. The American aircraft, scattered by combat and low on fuel, tried to find their carriers in pitch blackness. Carriers operating under wartime conditions maintained strict light discipline. No lights, no beacons, nothing to give away their position to enemy submarines. Pilots flew on dead reckoning and prayer, watching their fuel gauges drop toward empty. At 8:30 p.m., Admiral Mitchell made another controversial decision. Turn on the lights. Every ship in Task Force 58 lit up like a Christmas tree. Searchlights stabbed into the sky. Carriers turned on their deck lights. It was a massive violation of every rule about light discipline, a beacon that's screaming "We are here" to any Japanese submarine within 50 miles. But Mitchell wanted his pilots back. Even with the lights, it was chaos. Planes landed on the wrong carriers. Pilots, exhausted and fuel-starved, made bad approaches and crashed. Some aircraft ran out of fuel and ditched in the ocean just short of the fleet. Of the 216 aircraft that launched, 20 were lost in combat, but 80 more either crashed landing or ditched due to fuel exhaustion. 100 aircraft total, nearly half the strike force. But here's the critical point. Of those 80 aircraft lost to fuel exhaustion, most of the crews survived. Destroyers and submarines spent all night rescuing pilots and aircrew from the water. By morning, most of the men who ditched were back aboard American ships. The material loss was significant. 100 aircraft was no small thing. But the men, the trained pilots and crews who represented years of PUFIC training and experience, survived, and they'd accomplished something the Japanese had thought impossible. The Battle of the Philippine Sea marked the end of Japanese carrier aviation. Ozawa's fleet limped back to Japan with only 35 operational aircraft remaining. The carefully rebuilt carrier air groups, the pilots Japan had been training for a year to replace the losses at Midway and the Solomons, had been annihilated. Japan would never again be able to mount a carrier strike of any significance. When the carriers appeared again at the Battle of Leyte Gulf 4 months later, they were decoys, bait to draw American carriers away from the landing beaches. They had almost no aircraft aboard. The once mighty carrier force that had struck Pearl Harbor and rampaged across the Pacific for 6 months was finished. And it had been finished, in large part, by an American weapon system that exceeded every Japanese estimate of its capabilities. The TBF Avenger, carrying a Mark 13 torpedo, launching from carriers the Japanese thought were too far away to matter, had struck with devastating effectiveness. Japanese naval intelligence had calculated American strike ranges based on early war performance. They'd assumed, reasonably, that a torpedo-laden aircraft's combat radius would stay roughly constant. What they hadn't accounted for was American industrial capacity and engineering innovation. Between 1942 and 1944, the United States had not just built more carriers and more aircraft, they'd made those aircraft better. More powerful engines, better fuel systems, improved weapons, new tactics. The Avenger that attacked Hio in June 1944 could fly farther, hit harder, and survive more punishment than the devastator it had replaced. And it could do all of this from distances that Japanese admirals, working with outdated intelligence, had declared impossible. This is the hidden story of carrier warfare in the Pacific. It's not just about building more ships or training more pilots, though America did both of those things at scales Japan couldn't match. It's about constant incremental improvement, taking a weapon system and making it 5% better, then 5% better again, then another 5%. None of those individual improvements are war-winning by themselves. But compound them over 2 years and suddenly your torpedo bombers can strike from 275 miles instead of 200. Suddenly the enemy's carefully calculated safe distance isn't safe anymore. The Japanese made their plans based on what American aircraft could do in 1942. By 1944, those plans were obsolete, and Japanese industry, strangled by American submarines, bombed by American aircraft, couldn't keep up. Japan was fighting 1944 with 1942 capabilities. America was fighting with capabilities that improved every month. After the Philippine Sea, American carrier task forces ranged across the Pacific with near impunity. The Fast Carrier Task Force struck targets from the Philippines to Formosa to the Japanese home islands themselves. TBF Avengers participated in every major operation. At the Battle of Leyte Gulf in October 1944, Avengers helped sink the super battleship Musashi. At Okinawa, they provided close air support for the invasion. In July 1945, they struck Japanese shipping in the inland sea itself, in waters the Japanese had considered absolutely safe from carrier attack. The final toll tells the story. Over 9,800 TBF and TBM Avengers were built during the war. They flew over 46,000 combat sorties. They were credited with sinking 30 submarines, scores of surface ships, and helping destroy both Yamato-class super battleships. Loss rates for Avenger crews were remarkably low compared to the devastators they'd replaced. Out of nearly 10,000 aircraft built and tens of thousands of combat sorties, total combat losses were 729 aircraft, 422 to anti-aircraft fire, 47 to aerial combat, and 260 to operational accidents. For a torpedo bomber operating in the most dangerous environment imaginable, those numbers were extraordinary. The Avenger became the benchmark by which all other torpedo bombers were measured. The Japanese B-6N Tenzan was faster but lacked protection and range. The British Fairey Barracuda was capable but underpowered and short-ranged. Only the Avenger combined long-range, heavy payload, rugged construction, and multi-role capability. Only the Avenger could carry a 2,000-pound torpedo over 1,000 miles and still have fuel to fight and return home. And that capability, more than any single battle or engagement, changed the equation of carrier warfare. Before the Avenger, carriers had to close within 200 miles of a target to launch effective torpedo strikes. That put them within range of enemy land-based aircraft. It exposed them to submarine attack. It limited where carriers could operate and what targets they could hit. The Avengers' extended range gave American carriers flexibility. They could strike from farther out, stay safer, hit targets the enemy thought were out of reach. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. It transformed carriers from tactical weapons into strategic weapons. A carrier task force with Avengers aboard could threaten targets 500 miles from its position. That's an area of nearly 800,000 square miles. One carrier task force could control an area the size of Mexico. The Japanese never adapted. They never developed a long-range torpedo bomber to match the Avenger. They never improved the Kate to extend its range or increase its capabilities. Partly this was because Japanese industry couldn't keep up, but partly it was because Japanese doctrine didn't value the same things American doctrine did. Japanese naval aviation had been built around the idea of a decisive battle. One engagement where the entire fleet would commit and the war would be decided. Extreme range wasn't necessary for that kind of battle. You found the enemy, you closed with them, you struck, and it was over. The Americans, by contrast, had built their doctrine around sustained operations, carriers that could fight for months without returning to port, aircraft that could strike day after day. Longer range meant more flexibility. It meant you could hit the enemy without him hitting you back. It meant you could control a battle's tempo and distance. The Avenger embodied that philosophy. It was built for the long haul, built to hit targets far from the carrier, built to come home. On June 19th, 1944, when those 54 Avengers launched into the unknown, heading for a target 275 miles away, they proved a point the Japanese hadn't wanted to believe. American engineering had overcome the limitations Japanese intelligence said were absolute. American industry had built an aircraft that exceeded every performance estimate, and American pilots had the courage to fly a mission that looked like suicide on paper and came back to prove it could be done. Admiral Ozawa sat in the operations room aboard the light cruiser Nagara on the morning of June 20th, 1944, and tried to understand what had gone wrong. His staff was giving him the numbers, and the numbers were catastrophic. 3 aircraft carriers sunk or critically damaged, 350 aircraft lost, hundreds of trained pilots dead, and the American fleet, the fleet he'd been certain he would destroy in a decisive engagement, was still fully operational, still launching strikes, still hunting his remaining ships. What Ozawa didn't know, what Japanese naval intelligence wouldn't fully understand until after the war, was that he'd been fighting with obsolete information. The intelligence estimates that said American torpedo bombers couldn't reach beyond 200 miles were based on data from 1942. They were accurate then. The problem was that American aircraft in 1944 bore almost no resemblance to American aircraft from 2 years earlier. This wasn't unique to aviation. It was a pattern that repeated across every category of American military equipment in the Pacific War. Japanese commanders kept planning for the Americans they'd fought in 1942, Americans who had older fighters, unreliable torpedoes, inadequate radar, limited logistics. By 1944, none of that was true anymore. The F-6F Hellcat had replaced the F-4F Wildcat. The Mark 13 torpedo actually worked. Radar could detect aircraft 100 miles out and guide fighters to intercept. And the logistics network that supported American operations was unlike anything the world had ever seen. Let's talk about what that logistics network meant for the Avenger. Because the aircraft itself was only part of the story. A TBF Avenger didn't operate in isolation. It was part of a system. That system included the carriers that launched it, the fleet train that kept those carriers supplied, the repair facilities that maintained the aircraft, the training pipeline that produced the pilots, and the industrial base that built everything from scratch. The Japanese had seen the Avenger. They knew its specifications, at least the basic ones. What they didn't see, couldn't see, was everything behind it. An American fleet carrier in 1944 was a floating city. The USS Essex, the lead ship of the class that became the backbone of the fast carrier task force, displaced 36,000 tons fully loaded. It carried 90 to 100 aircraft. The crew numbered over 2,600 men. But that carrier didn't operate alone. Each carrier had an air group, which included not just the pilots but maintenance crews, ordnance specialists, radar operators, flight deck crews. The carrier was escorted by destroyers, cruisers, fast battleships, and behind all of that was the fleet train. The fleet train was the secret weapon of American carrier operations. It was a floating supply line that allowed carriers to stay at sea for months without returning to port. Oilers carried fuel, ammunition ships carried bombs, torpedoes, and shells. Repair ships carried spare parts and machine shops, even floating dry docks that could repair damaged ships at sea. This fleet train meant that American carriers could operate thousands of miles from the nearest base and never worry about running out of fuel, ammunition, or spare parts. The Japanese had nothing comparable. Japanese carriers in 1944 were operating from bases in the Philippines or Japan itself. They had to return to port regularly for fuel and supplies. The American submarine campaign had devastated Japan's tanker fleet, which meant getting fuel to the carriers was increasingly difficult. Japanese carriers, in June 1944, were actually running on partially refined Borneo crude oil because they couldn't get enough refined fuel. That crude oil was dirty, inefficient, and left deposits in engine fuel lines that reduced performance and increased breakdowns. Meanwhile, American Avengers were running on high-grade aviation fuel, delivered by dedicated tankers that never had to worry about submarine attack because the US Navy controlled the sea lanes. The difference in fuel quality alone probably gave American aircraft a 5 to 10% range advantage. Multiply that by every other advantage, every small edge in logistics and supply, and you start to understand why American aircraft could do things Japanese intelligence said were impossible. But logistics only mattered if you had something to supply. The real revolution was in American industrial production. Between January 1942 and August 1945, American factories built 9,839 TBF and TBM Avengers, 9,800 aircraft of a single type. The Japanese built about 1,200 B-6N Tenzans, their closest equivalent, during the entire war. American production was roughly 8 times higher for just this one aircraft type. And it wasn't just quantity. American production methods meant that aircraft rolling off the line in 1944 were better than aircraft built in 1942. Grumman and General Motors constantly incorporated improvements: better engines, stronger wings, more reliable systems. An Avenger, built in June 1944, the TBM-3 variant, had upgrades that made it objectively superior to the TBF-1 that had flown at Midway. More power, more range, better weapons. The Japanese couldn't do this. Japanese aircraft production was mostly hand-built, with limited standardization. Improving a design meant retooling entire factories, which Japan couldn't afford to do. General Motors' Eastern Aircraft Division alone built over 7,500 Avengers during the war. GM had taken Grumman's design, reverse-engineered it for mass production, and churned out aircraft at rates that would have seemed impossible in 1941. They did this while also building trucks, tanks, artillery pieces, and everything else the military needed. American industrial capacity was so overwhelming that the same company could build thousands of aircraft and thousands of trucks simultaneously without either production line suffering. The Japanese knew they couldn't match American production. They'd known that since before Pearl Harbor. What they hadn't understood was how that production advantage would manifest in combat. It wasn't just about having more aircraft. It was about having better aircraft. About being able to afford losses that would cripple Japan. About having such an abundance of equipment that commanders could launch risky strikes, knowing that even if they lost half the aircraft, replacements would arrive within weeks. Look at the numbers from the Philippine Sea strike on June 19th. The Americans lost 100 aircraft to fuel exhaustion. 100 aircraft. For Japan, That would have been a catastrophic loss that would take months to replace. For the United States, it was a bad day that was made good within 2 weeks. Replacement aircraft arrived from Pearl Harbor. New pilots, already trained, were transferred from stateside squadrons. By early July, Task Force 58 was back to full strength and launching strikes against the Bonin Islands. This industrial advantage extended to every piece of equipment the Avenger used. The Mark 13 torpedo had been a disaster at Midway. Slow, unreliable, fragile. The Bureau of Ordnance at the Naval Torpedo Station in Newport, Rhode Island, had made fixing the Mark 13 their highest priority in 1942. They ran hundreds of tests. They tried different designs for stabilizing fins, nose cones, depth settings, fusing mechanisms. They tested drop speeds, drop altitudes, water entry angles. By late 1944, the Mark 13 Mod 2 was a completely different weapon. The improvements were specific and dramatic. The original Mark 13 had to be dropped below 100 feet at speeds under 130 miles per hour, or it would break apart on water entry. The Mod 2 could be dropped from 800 feet at speeds up to 260 knots. That single change transformed torpedo tactics. Avengers no longer had to make slow, low approaches through anti-aircraft fire. They could come in fast, from altitude, and still deliver reliable attacks. The torpedo's range also improved. Early Mark 13s ran about 6,000 yards at 33 knots. Later versions could reach farther or run faster, depending on settings. The warhead increased, from 400 pounds of TNT to 600 pounds of Torpex. Torpex was a British innovation, a mixture of RDX, TNT, and aluminum powder that was about 50% more powerful than TNT alone. American industry scaled up Torpex production so quickly that by 1944 it was standard in most Navy torpedoes. These improvements came from a combination of British technology sharing, American engineering, and the freedom to test and fail without catastrophic consequences. The British had developed the wooden stabilizing fins that allowed shallow water torpedo drops at Taranto in 1940. American engineers studied those fins, improved the design, and adapted them for the Mark 13. That kind of international cooperation and rapid innovation was something the Axis powers, for all their early advantages, couldn't replicate. Japan's torpedo technology had actually been superior at the start of the war. The Type 91 aerial torpedo used at Pearl Harbor was faster, longer ranged, and more reliable than the American Mark 13 of 1941. But Japanese torpedo development essentially stopped in 1942. The Type 91 used in 1945 was almost identical to the 1941 version. There were no significant improvements in range, speed, or reliability. Japanese industry couldn't afford the kind of massive testing and development program the Americans ran at Newport. The same pattern held for aircraft engines. The Wright R2600 engine that powered the TBM-3 produced 1,900 horsepower from 14 cylinders. It was reliable, powerful, and could run on the high-octane fuel American refineries produced in massive quantities. Japanese engines in 1944 were increasingly suffering from quality control problems. Replacement parts were scarce. Maintenance was difficult. American engines, built with standardized parts by skilled workers using advanced machine tools, simply worked better. Even something as simple as paint mattered. American aircraft in the Pacific switched to a dark blue color scheme in 1944. This wasn't just aesthetic. The dark blue made aircraft harder to spot against sky and water, especially in the low-light conditions of dawn and dusk attacks. The paint itself was formulated to resist saltwater corrosion and tropical heat. Japanese aircraft paint, by 1944, was often substandard due to material shortages. Paint that flaked off in the tropical environment, exposing metal to corrosion, reducing aircraft lifespans. Add up every small advantage, and the Avenger becomes something more than just a good torpedo bomber. It becomes a symbol of American industrial and technological superiority. The aircraft itself was well designed. Leroy Grumman and his engineers had created a rugged, practical machine, but what made it devastating was everything behind it. the supply chain that kept it flying, the maintenance crews that kept it operational, the training pipeline that produced skilled pilots, the industrial base that built thousands of them, the research facilities that kept improving every component. This is what Japanese intelligence missed when they calculated that American torpedo bombers couldn't reach beyond 200 miles. They looked at the aircraft. They should have been looking at the system that could take a good design and make it better, the system that could produce thousands of aircraft and keep them all supplied and maintained, the system that could absorb losses that would cripple any other nation and come back stronger. By late 1944, the Pacific War had become a war of attrition, and in a war of attrition, industrial capacity was everything. Japan started the war with better trained pilots, more combat experience, and equivalent or superior technology in many areas. But as the war ground on, those advantages evaporated. The veteran pilots were dead, the technological edge was gone, and Japanese industry, never able to match American production even under ideal conditions, was being systematically destroyed by American submarines and bombers. The Avenger raids that struck the Japanese home islands in summer 1945 were launched from carriers operating with impunity in waters. Japan had once controlled absolutely. Avengers hit targets in Tokyo Bay, the Inland Sea, Kure Naval Base. They sank the battleship Haruna at her moorings. They destroyed what remained of the Japanese merchant fleet, and they did all of this from carriers that operated hundreds of miles offshore, far beyond the range where Japanese commanders in 1942 would have said they were vulnerable. The Japanese surrender in August 1945 ended the war before American forces had to invade the home islands. But if that invasion had happened, Avengers would have been part of it. They would have provided close air support for landing forces. They would have struck Japanese positions far inland using their bombs and rockets. The torpedo bomber that had been designed to sink ships had evolved into a multi-role attack aircraft capable of hitting any target within hundreds of miles of the fleet. After the war, the Avenger remained in service for decades. The US Navy used them for anti-submarine warfare well into the 1950s. The Royal Canadian Navy flew Avengers until 1960. They were modified with radar, sonobuoys, and acoustic torpedoes designed to hunt submarines. The basic airframe was so robust and the design so practical that it remained useful long after most World War II aircraft had been scrapped. Some Avengers even found civilian use. They were converted into aerial firefighting aircraft, water bombers that could drop thousands of gallons on forest fires. The large internal bomb bay that had once carried torpedoes now carried water or fire retardant. Canadian and American forestry services operated Avenger water bombers into the 1970s. A few are still flying today, lovingly maintained by collectors and warbird enthusiasts, testament to how well Grumman built them 70 years ago. But the real legacy of the Avenger isn't in the museums or air shows. It's in what the aircraft represented. The Avenger was proof that wars are won not just by brave men, though courage matters, but by logistics, by industry, by the ability to build better tools and use them effectively. The Japanese made their plans based on what American aircraft could do in 1942. By 1944, those plans were obsolete, and Japanese industry couldn't adapt fast enough to matter. Every TBF Avenger that launched from a carrier deck carried with it the full weight of American industrial might. The steel mills of Pittsburgh, the assembly lines of Detroit, the oil refineries of Texas, the training fields of Florida, the research labs of Rhode Island, all of it concentrated into one aircraft, flown by one pilot, delivering one torpedo to one target, and when that torpedo hit, when a Japanese carrier broke apart and sank, it wasn't just the Avenger that sank it. It was the entire system that produced the Avenger, supplied it, maintained it, improved it, and sent it into battle. Admiral Ozawa learned this lesson on June 19th, 1944, when American torpedo bombers struck his fleet from a range he'd calculated was impossible. The lesson cost him his carriers, his aircraft, and any hope Japan had of winning the Pacific War. It was a lesson written in steel and fuel and explosives, delivered by men who flew farther than the enemy thought possible, in aircraft built by a nation that could afford to build thousands more. The Japanese never expected TBF Avengers to carry 2,000-pound torpedoes 1,000 miles from carriers. They based their expectations on old information, on capabilities from an earlier phase of the war. They didn't account for American engineering, American industry, American logistics. That miscalculation cost them everything. And the men who flew the Avengers, the mechanics who maintained them, the workers who built them, proved that sometimes the most important battles aren't fought with courage alone. Sometimes they're won in factories, in shipyards, in research facilities, by people who never saw combat but built the weapons that made victory possible. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.